This discussion will explain the theory behind the element recommendation comparison graphs, and the practical implications for the farmer. The idea behind this graph is to show the deviation of elements applied using various methods of deduction. The principle is that the zero vertical or y-axis value represents the long-term element recommendation for the week. The first three data sources show estimated deviation based on long-term irrigation schedule forecasts. So, in a perfect world, the irrigation plus non-irrigation applied fertilizer should be on the zero value of the vertical axis. However, because of compromises that have to be made due to the limitations imposed on you by your tank system, this is not always possible. The objective here is to point out situations where your fertigation system is significantly over or under supplying an element. As described in the overview video, you can simplify the graph using the split by button. As an example of what might be occurring, one element, for example potassium, may be consistently over-applied in one field and another consistently under-applied. However, in another field on the same fertilizer mix, the reverse is happening. This could be because the program is making the best compromise of the application requirements across the two fields. In this case, you should review the calculation methods used in your fertilizer mix and decide if it is the best under these circumstances. Perhaps you should select minimum and make up any under-applications with an alternative fertilizer and application method. In another situation, there may be consistent over or under-application across all fields on the same line, of an element or elements. This may require an adjustment to the injection rate. Just do not forget that you have done that, and change it back if, or when, necessary. If you are just applying fertilizer via the irrigation system, then the irrigation applied rec deviation graph will suffice for information. Please note that if a quantity of element is recommended but zero is applied, the deviation defaults to -100%. If deviations exceed the range of -100 to 100%, then the value at these limits is capped. Hover your mouse over that point to get the correct percentage deviation. The appearance of this non-irrigation applied graph will depend on whether or not non-irrigation applied fertilizers are part of your fertilizer mix, for example as corrective fertilizers. This will help you to assess if it is important to apply corrective fertilizers. The irrigation schedule assumes that you are following the AgriWiz irrigation schedule and fertilizer injection rates and then extrapolates the quantity of element applied. Therefore, if on average for the week, the weather requires more water than the long-term average, then you will apply more of the element. If you believe that a plant using more water means it needs more fertilizer, you can leave things as they are. Otherwise, you might want to reduce the tank injection rates. Do not forget to change the injection rates back again, when necessary. The controller log graph is derived from the actual volume of water delivered, according to the controller logs, and the fertilizer injection rates and then extrapolates the quantity of element applied. The irrigation mobile log graph is only available if you are recording irrigation field data on the AgriWiz mobile app. The quantity of elements supplied will be averaged across the monitoring stations, if there is more than one. There will be an EC graph for each monitoring station in the field. A divergence in these graphs may indicate an emitter problem that needs to be addressed. This video has given you further insight into the element recommendation deviation graphs. Consult your agronomist for specific actions to take if you have concerns.